1. The journey to Mars. By the end of this decade, humans may take their first steps on Mars, marking a major milestone in space exploration. According to NASA and experts, permanent settlements on the red planet could become a reality by 2050. This means that people living today might be among the first pioneers of a new world. However, reaching Mars is no easy task. The journey takes about 3 months, but the risks are enormous. Once astronauts leave Earth, they will no longer be protected by its magnetic field. This exposes them to harmful solar and cosmic radiation, which can increase the risk of cancer or even cause neurological damage, leading to symptoms similar to Alzheimer's disease, possibly even before they arrive on Mars. To counter this danger, scientists have proposed several protective measures. One possible solution is to build spacecraft using hydrogen-rich materials, which can effectively absorb radiation. Another idea is to surround the ship's cabin with water tanks, as water is also rich in hydrogen and can help block radiation. A more ambitious approach is to generate an artificial magnetic field around the spacecraft, but this would require an enormous amount of energy, far beyond our current technology. 2 conditions on Mars. Mars shares some similarities with Earth, particularly in its day and seasonal cycles. A Martian day, or sol, lasts about 24 hours and 39 minutes, almost the same as an Earth day. The planet also has seasons because its axis is tilted at 25 degrees, close to Earth's tilt of 23.5 degrees. However, the climate on Mars is far more extreme and unpredictable. Temperature fluctuations on Mars are drastic. During the winter at the poles, temperatures can plummet to a bone-chilling 143 degrees Celsius. In contrast, summers near the equator can be surprisingly warm, reaching up to 35 degrees C. Despite these occasional warm spells, the planet's thin atmosphere makes it nearly impossible to retain heat, leading to freezing conditions most of the time. One of the most fascinating features of Mars is its polar ice caps, which are primarily made of water ice rather than frozen carbon dioxide. These ice caps expand in winter and shrink in summer. Dust storms and their impact on Mars. Mars is notorious for its massive dust storms, which can grow so large that they cover the entire planet. These global storms occur approximately every 5.5 Earth years, or about 3 Martian years, and can last for weeks or even months, significantly altering the planet's climate during that time. The primary cause of these storms is the extreme temperature difference between day and night, which can reach up to 75 degrees. This temperature variation creates powerful winds that stir up fine Martian dust. Unlike Earth, where the atmosphere helps settle airborne particles, Mars has an extremely thin atmosphere, less than 1% of Earth's atmospheric pressure, allowing dust to remain suspended for long periods. One of the most striking phenomena on Mars is the presence of dust devils, gigantic swirling columns of dust that can reach heights of up to 8.5 kilometers. These dust devils play a crucial role in lifting dust into the atmosphere, contributing to the formation and longevity of larger storms. Once airborne, the dust absorbs sunlight, further heating the atmosphere and strengthening wind currents, creating a feedback loop that sustains the storm. These storms pose serious challenges for robotic and future human missions. The thick dust clouds can block sunlight for extended periods, crippling solar-powered equipment and reducing visibility. Understanding and preparing for these dust storms is essential for any long-term exploration or settlement plans on the red planet. While Mars may appear somewhat Earth-like in certain aspects, its harsh and volatile climate poses significant challenges for future explorers and settlers. Impact on equipment and survival on Mars. Dust storms on Mars pose a significant threat to both robotic missions and future human explorers. One of the biggest challenges is their ability to block sunlight, which is essential for solar-powered equipment. For example, NASA's Spirit and Opportunity rovers suffered severe energy shortages due to dust accumulating on their solar panels. The Spirit rover became immobilized in 2009, and by 2011, NASA officially declared the mission lost after failing to restore communication. Unlike on Earth, where strong winds can cause physical damage, Mars' thin atmosphere means its winds exert much less force. However, the real danger comes from fine dust particles that can infiltrate mechanical systems, clog filters, and cause long-term wear on machinery. This dust is electrostatically charged, making it stick to surfaces, further complicating maintenance and cleaning efforts. Conclusion: the challenges and future of Mars. Colonization. Colonizing Mars is not just a dream, it is a possibility within our lifetime. However, the journey to making the red planet a second home comes with extreme challenges. Radiation exposure, harsh climate conditions, and massive dust storms pose serious threats to both human explorers and robotic missions. Surviving on Mars will require advanced technology and careful planning. To establish a sustainable presence, scientists and engineers must develop radiation shielding, efficient energy sources, and protective habitats to withstand the planet's severe environment. Innovations such as self-sustaining life support systems, autonomous robots, and nuclear power stations could play a vital role in ensuring long-term survival. Despite these challenges, the potential rewards are immense. A successful Mars colony could serve as humanity's first step toward becoming a multiplanetary species, ensuring our survival beyond Earth. With continuous advancements in space technology, the dream of living on Mars may become a reality within the next few decades. The question is not if we will get there, but how soon. For long-term survival on Mars, new technology solutions are required to mitigate dust-related risks. Potential innovations include self-cleaning solar panels, protective coatings for machinery, and alternative power sources such as nuclear reactors, which are not dependent on sunlight. Additionally, habitats and spacesuits must be designed to minimize dust infiltration, as inhaling Martian dust could pose severe health risks to astronauts. As space agencies and private companies plan future missions, overcoming the challenges of Martian dust will be crucial for the success of long-term exploration and colonization efforts.